Hello again, everybody. This is Mr. Pagachnik, and we will be talking about stars and our sun in the 5.3 guided notes. So when you look out into the night sky, you're going to see many objects. So looking at that picture, you're looking across the Milky Way galaxy, so you're seeing those clusters across the middle. But you're also seeing probably some things that aren't part of our galaxy, like other galaxies. But the most common thing you're going to be seeing, especially in that area, are stars, other stars, stars within our galaxy. So how many are there in the universe? And how many are there in the Milky Way? Well, those are some pretty big numbers, and they're pretty hard to come by. Now, the life cycle of a star is a little bit more known. Stars actually have a life cycle, and some will die in very spectacular fashion. So if you look at this, you'll see they typically start in a nebula, and they could become an average star, kind of like our sun, which then will expand into a red giant, and then the outer layers will blow off, and all that'll be left is the center, which is called a white dwarf. Now, if the star became a much bigger star, it could turn into a red supergiant and then undergo a supernova, which a supernova can blow up and it could turn into either a black hole if it has enough gravity, or it can turn into a neutron star. So what are the common types of stars? The most common types are the brown dwarf, the red dwarf, the yellow dwarf, the white dwarf, the blue giant, the red giant, and the red supergiant. The red supergiant, of course, being the biggest. Ours would be considered a yellow dwarf star. Now, looking at some different sizes, a red dwarf is about 140,000 miles across. So that's the small one. That's Wolf 359. And that's next to our sun, and that's next to Sirius. Then you go to the next picture to the right and look at how small Sirius is compared to the next couple. And then Aldebaran is then the small one on the next picture. And then Betelgeuse, or Betelgeuse if you want to go that route, is very small compared to VY Canis Major. To compare the two, the red dwarf is 140,000 miles across, and VY Canis Major is 1.227 billion miles across. 1,227,000,000 miles. That's huge. Now, there's a relationship between brightness and temperature. If you look at this picture, what it shows is that the temperature of a star and its luminosity or brightness can be plotted out. Most of the stars kind of fall in that big pile that goes across from top left down to bottom right. The sun, our yellow star, is kind of right in that middle, and it's only looks yellow. It's actually pretty white, and it's quite average too. You can get some cool and bright ones in the top right-hand corner, and then you get some kind of, some hot and dim ones down towards the lower left, like white dwarfs. But ours is kind of right in the middle. It's called a main sequence star. How do stars produce heat and light? Well, that would be nuclear fusion. That's what powers a star. There are layers of fusion, like layers in an onion. Fusion is when two small atoms smash into each other and their nuclei stick together and make a bigger atom. That's called fusion. They are fusing together. And when they do that, they give off a lot of energy. And there are different types of fusion happening. There's hydrogen fusion, where hydrogens are fusing into helium. There's helium fusion, carbon fusion, oxygen fusion, all kinds of different layers of fusion going on. Now, focus on our star, which we call, of course, the sun. It's very average. There's nothing really crazy about it. It's not really all that big, and it's not really all that massive. It's, pretty average star. Now, it's really large compared to our planet. It's 865,000 miles across. The Earth is about 7,900 miles across. There are parts. There are, areas to the sun, like there are parts of the Earth. There's a core, and that's the hottest, about 27 million degrees Fahrenheit. Then you got the radiative zone, the convective zone, and then on the very outside you have, it's like the corona, the photosphere and the corona. The corona is the part that actually kind of shines. That's the part you could see during an eclipse if you block out the middle. There's different types of solar activity. There are solar prominences and solar flares, which look very similar to one another, and there are sunspots, which are kind of cool areas. They're dark looking areas in the sun. Now, some facts about the sun. It's about 109 times as wide as our planet. It's about 330,000 times more massive than our planet. It's a main sequence star, so it's pretty average. It's about 73% hydrogen, 25% helium, and then a couple percent other elements. It's about 4.6 billion years old. It's a yellow dwarf, although it looks white. So we see it as kind of yellowish, but it's actually white. That's caused by our atmosphere. It's got about 5 billion years of life left, so it's about middle-aged, we'd say. And it will probably turn into a red giant. It'll blow off the outer layers, it'll kind of explode away, and then it'll wind up a small white dwarf. Now in the picture you can see the sun, then Jupiter, the biggest planet, and then that little dot is the Earth. Now a few other solar facts. It is the center of our solar system. The sun is in the center, and everything is revolving around the sun. And that's all we're going to talk about. So a couple different things to kind of focus on is what creates the heat in the sun? What do we know about the sun? What do we know about its life cycle? Those are some facts to take away.